So, first of all, we will talk about what are the conditions which are required in order to generate the voltage in any coil, right? Because you know that in any single phase machines or two-phase machine, or it may be a three-phase machines, we use different type of coils. Last class, we have also discussed about the presence of the different coils like field coil and armature coil. So there are certain conditions which must be present in order to produce the electrical current in any system. So the different things are first one is your magnetic field, then another one is your conductor, or you can also say it as a coil. This is basically a coil. Then there should be relative motion between the magnetic field or flux and the conductor present in any system in order to produce the EMF or electrical current through that coil or conductor, right? So conductor cuts when the conductor cuts the line of magnetic flux, a voltage is induced in the conductor. This is due to the principle I have already discussed. Means E is equal to minus N d phi by dt. So this d phi by dt is basically your rate of change of flux through the conductor. So when rate of change of flux occurs, then in that condition EMF will induce. Now there are different conditions, like suppose if you have a conductor, if this is a conductor, suppose a single conductor we are using. If this is a conductor A and A dash, and suppose in the first condition this is a static, this is not moving or revolving, right? Now the flux in this condition should be time varying or revolving in nature in order to produce the current or EMF in this particular A dash coil. So first condition is that your flux should be variable or rotating or time varying, whatever, variable. Only in that condition rate of change of flux will occur, right? Because suppose if flux is also constant and your conductor is also static, then this d phi by dt will be zero, right? So no EMF will induce. Second condition is that when your flux is suppose static, this is a constant flux, and in that condition the conductor is moving or rotating either clockwise or anti-clockwise. So due to the motion of the conductor, there will be rate of change of flux in the conductor. So even if the flux is constant, there will be rate of change of flux due to the motion of the conductor, and hence EMF will induce. First condition was flux should be variable and your conductor was static. In the second condition, conductor moving and flux constant. And third condition may be when both are moving with respect to each other. So in that condition also rate of change of flux will occur, and hence EMF will induce in the conductor, right? So you will see these possibilities, these three possibilities in different machines which are available in electrical systems, right? Later on you have to study single phase transformers. So you know that transformer is a static device. So in that condition you will see your conductor will be static but flux will be time varying. So first condition will be fulfilled, right? Now in case of suppose DC machine, when you will study DC machine in this syllabus later on, you will see that your conductors are moving and the flux are constant. Flux is constant due to the DC supply. Your flux will be also static in nature, but we are rotating the conductor. In that condition you will realize the uh, second condition, right? And there are different other machines also in which you will see that both are moving with respect to each other. So these are the three conditions which should be satisfied in order to produce the electricity or electric current through any conductor. This principle is known as Faraday's law. Now this we have already discussed. Just through some graphical representation, we will see how the generation of a single phase EMF or current is possible. So here you can see that we have two poles, south pole and north pole. So this combination basically forms your pole pair. So one pole pair means you have a combination of north pole and south pole, right? तो इसमें देख रहे हो, here you can see that we have a conductor. This is your conductor, orange one. So basically machine में क्या होता है, किसी भी machine में we have a stator and rotor. So conductors are wound in the slots provided on the stator और आर्मेचर. तो ये जो है यहाँ पे देखोगे, अगर एक कॉइल है ए डैश्ड, देन यू हैव बी डैश्ड, then you have C dash. This is for a three phase system. Similarly, for a single phase system, you can consider it like this. You have a single coil A dash. So here this represents a single coil. So if here in a conductor it is dot, then in another it will be cross. Dot means current is, this is just a convention, dot and cross. So what is the significance you will study later on in the machine part. So for the time being, just you understand that dot signifies that the current is coming outside the conductor. मतलब upward आ रहा है, A से बाहर आ रहा है. And cross means it is going inside. You know that if there is a conductor, मतलब कोई भी अगर system है, मान लो ये अगर supply है, and if you have a coil in this form, then if current is entering from one point, then it will leave the another point of the conductor. So similarly, in the same way, you can understand that here current A से बाहर आ रहा है and A dash के अंदर जा रहा है. ठीक है. So here you can see that the flux lines are this one, this pink color you can say, means from north pole towards the south pole. This is in the direction of the magnetic field or flux, as mentioned in this figure. So you can see that here at this instant of time, the motion of the conductor is parallel to the flux. Conductor we are assuming is going to rotate in the clockwise direction, right? So at this point no voltage will be induced, right? जो फ्लक्स है वो मैक्सिमम इसके थ्रू है, कंडक्टर के थ्रू द फ्लक्स इज मैक्सिमम, बट रेट ऑफ चेंज ऑफ फ्लक्स इज जीरो, राइट? फ्लक्स कटिंग कुछ नहीं हो रहा है. अगर ये अपना पोजीशन चेंज करेगा स्लाइटली, then the same amount of flux will cut the conductor. So nearly the flux linked with the conductor will be same, and hence rate of change of flux will be zero. So no EMF will induce at this point. So that's why you can see the blank screen here on this graph. Now the second case, when suppose the conductor has rotated by some angle, you can consider that angle as, suppose this is 45 degree. So when the conductor rotated by 45 degree in clockwise direction, so in this condition, you can see that voltage has been generated up to some point corresponding to the motion of the conductor, which is nearly equivalent to the 45 degree, right? This is 45 degree. So here the rate of change of flux occurs through the conductor, and hence the EMF started to generate through that coils. Suppose this is A, this is A dash. In this way you can realize. Now another instant when you can say that when the conductor rotated by 90 degrees, so in this condition the motion of the conductor is perpendicular to the flux, right? यहाँ से देखो अब जो स्टार्ट करेगा रोटेशन, तो ये परपेंडिकुलर होगा फ्लक्स के. सो इन दिस कंडीशन व्हाट विल हैपन? इन दिस कंडीशन इंड्यूस्ड वोल्टेज अक्रॉस दीज कॉइल्स व्हिच वाज सपोज दिस ए डैश. सो ए डैश कॉइल के थ्रू जो voltage होगा, that will be maximum at this instant. It will reach the peak value of the EMF, right? Again what will happen when the position of the conductor is changed again by suppose 45 degree from the vertical position, or from this axis, इसको बोलते हैं direct axis. So what will happen? It will again reach the value here, means 0.707 of the maximum peak value of the EMF. So similarly due to the change in the position of the conductor, what will happen? There will be continuously decrease in the EMF generated, and again at this instant, what will happen? This EMF will be EMF generated across the coil will be zero, because no rate of change of flux will take place again at this position. Means same position, ये और ये, but now the condition will change, because initially this green conductor was under the influence of south pole and the orange conductor was under the influence of north pole. But if this conductor will again rotate in the clockwise direction, then the green conductor will come under the influence of north pole. So the direction of the current or the polarity reversal will take place in the coil A and A dash. This green one was your A and this one A dash. तो इसमें क्या होगा? पहले यहाँ तुम लोगों ने देखा होगा कि ग्रीन में क्या था? देखो पिछला जाओ, ग्रीन में क्या था? क्रॉस, मीन्स करंट वाज गोइंग इनसाइड द ग्रीन कंडक्टर, और इसमें डॉट था ऑरेंज वाले में. नाउ व्हाट विल हैपन आफ्टर दिस पोजीशन? the direction of the current will change in the two coils of this conductor. Green may now it is dot and here it is cross. So due at this position, it means that now your voltage or current is going to induce in the negative direction. ठीक है? Current in the conductor has reverse, that is current reversal of the conductor has taken place, and therefore you will see that this current or voltage is going now in the downward direction or in the negative direction. So again this will attain the peak value for this position of the two coils of this conductor. This will attain the negative peak. Negative peak will be achieved, and again when it will come to the 45 degree, you will see that the 0.707 of the peak value in the negative direction will be achieved. And when this conductor will come in the original position, then what will happen? You will see that zero voltage is generated here. This signifies, this position signifies your zero EMF, because again there will be no rate of change of flux through the two coils of this conductor A and A dash. So in this way, the generation of the voltage and current actually takes place in a single phase system. Now same thing happen in case of three phase system also. But what is the change? अच्छा, इसमें किसी को कोई कंफ्यूजन? सिंगल फेज का जनरेशन जो अभी था, हाउ द पोजीशन ऑफ द कंडक्टर changes the generated EMF and current. Any confusion in this part? हेलो,
आगे समझ.
ठीक है, आवाज नहीं आ रही है, चलो ठीक है.
Yes,
Now,
sir.
okay. So now we will you can just means correlate this three phase system or three phase generator with a single phase system. Means earlier we have considered only two coils, A and A dash. Now what we have discussed in the last class for a three phase system, that the three coils are there in any three phase machine, and these three coils are separated from each other in a space by 120 degree. So you can see that here we have A, B and C, three coils, one side of the three coils, and another sides are A dash, B dash and C dash. So three coils here we have used A dash, B dash and C dash, and these coils are separated from each other in a space by 120 degree. So each coil is for a separate phase, right? Like A phase we have A dash coil, for B phase we have B dash, and for C we have C dash coil. Now the generator consists of a rotating magnet surrounded by a stationary winding, right? तो इसमें दोनों possibility actually हो सकता है कि either your field winding is rotated or the armature winding, both means armature winding is rotated and field winding is static. तो दोनों possibilities हो सकता है, but it has been observed that in case of three phase system, when you're especially I'm talking about generator, alternator or three phase synchronous generator, both are same. तो इसमें it has been observed that the system is economical as well as efficient if your field is rotating and armature is static. This is one possibility. So this configuration of the three-phase system is economical as well as efficient, right? Another possibility is also there, means when your field is static and the armature is rotating. But in that case, we have to use some additional devices like more number of slip rings in the machine in order to separate the rotating and static part of the machine. वो सब बात का बात है, वो सब synchronous machine में जब पढ़ोगे तो देखोगे. So the three separate windings or coils with terminals A dash B, A dash B B dash and C C dash are spaced 120 degree apart from each other, right? As the rotor rotates, its magnetic field cuts the flux from the three coils and induces voltage in the coils. This is again your Faraday's law of electromagnetic induction. Nothing new in this. The induced voltage will be equal in magnitude. Magnitude same hoga, but out of phase by 120 degree. These things we have discussed. So now. Suppose here, as we have seen in case of single phase system, means we have used a single coil. So in this way, you can consider here that your conductors, three phase conductors are moving and your field is static. Means second case we have considered here, right? So what will happen? Here we have considered three identical coils. Three identical coils placed with their axis 120 degree apart from each other and rotated in a uniform magnetic field, right? So what will happen? So when this process is implemented, a sinusoidal voltage will be generated across each coil. This is due to again the Faraday's law of electromagnetic induction, right? So इसमें you will get, because we have used the three conductors or three coils, so each coil is representing each phase. Suppose phase 1, phase 2 and phase 3. So you will see that this type of voltage or current you will obtain when the three coils will be rotated in a uniform magnetic field, right? So इसको अगर if you want to suppose represent it with the help of a phasor diagram, and then what will be the sequence? Suppose if this represents for phase A, this for phase B, and this for phase C, as we have considered earlier. So if you take this V A dashed, means A dashed are the two sides of the coil in phase A, right? So if we take this as the reference axis, the voltage generated across coil A dashed on the reference axis, then this will be your V B B dashed, and this will be your V C C dashed. right? So now the sequence of this voltage means whether it will be VCC dash or VVB dash, this depends upon basically the direction of rotation, whether we are rotating the coils in the clockwise direction or anti-clockwise direction, right? मान लो कि here, if as we have considered here that we are rotating it in the clockwise direction, so depending upon the rotation of the coils in the magnetic field, the sequence of the EMF will change, right? Means how it will affect, we will just see. You know that these relations are already known to you, that all the EMF generated will be separated from each other by 120 degrees. So how the sequence is affected, so इसको और डिटेल में हम लोग देखते हैं. मान लो same system we are considering again here. This way you can understand. Suppose this is north pole, this is south pole, and let us consider the three coils in this space. Suppose this is A dashed. Suppose this is B dashed. This is C dashed. Right. So here we have considered three coils. Now this is the position of coil for zero voltage. We have just seen in case of single phase system that at this position the EMF generated will be zero, right? And this position is for maximum voltage, right? So if we consider the anti-clockwise rotation, then you will get this set of sequence A dashed, B dashed, C dashed. You can also represent, this is 120 degree, all are 120 degree. You can also represent this in terms of the instantaneous values of the voltage generated, means at different instant of time. Suppose here we consider the voltage and this is your time axis. So in this way, right? So this is the three phase. Now you tell me, ये कौन सा होगा? Which phase voltage will be this one? Hello? Look, am I audible or not?
Yes, sir, you are audible, sir.
So you can see that at zero instant of time, initially when we have just started the rotation of the conductor in anti-clockwise direction, so the voltage generated in coil A dashed was
Zero.
will be zero. So here you can see at instant t is equal to zero, voltage is zero in this solid curve. So this will represent your A dash. That is the voltage generated across the coil A dash. Right. Now there will be 120 degree phase difference between the voltage generated in the coil B dash. Right. मीन्स ए से बी का जो फेज बी का जो ए से फेज डिफरेंस है वो 120 डिग्री एंड फॉर सी इट इज वन माइनस प्लस 120 डिग्री और माइनस 240 डिग्री. So this will be your V B dashed and this will be your VCC dash, right? That is, the coils are identical. Since the coils we have considered are identical, therefore the generated voltage will have the same magnitude, but there will be a phase difference of 120 degree between the generated voltage in the each coil, right? Also, it can be seen that uh, the three voltage, the three generated voltage reach their peak or maximum values in the order VAA dashed, then VBB dashed, then VCC dashed. So the phase sequence here will be A, B, C. Now, if anybody asks you to define the phase sequence, what do you mean by phase sequence? So you should tell the order in which the phase voltages, the order in which the generated phase voltages reach their maximum values is the phase sequence of that three phase system. So this is important point जो कि बहुत जगह यूज होता है. The order in which the phase voltages reach or attain their maximum values is known as phase sequence, right? So here for the anti-clockwise direction we are getting the phase sequence as ABC, means voltage will reach the first peak here in case of A coil, then B coil, then C coil, right? Now suppose if we change the rotation of the conductor.
Hello, sir.
Hello.
Hello, sir. Sir, am I audible?
हेलो.
Sir, am I audible?
हाँ बताओ.
सर इस वाले केस में तो सर सी वाला जो हमने ग्राफ बनाया है सर उसमें तो वी सी सी पहले पीक पे पहुंच जा रहा है ना सर अपने अगर टाइम के हिसाब से देखें तो सर तो इसमें
कौन सा?
सर ये जो हमने ग्राफ बनाया सर फेजेस का वी ए डैश वी बी बी डैश वी सी सी डैश
हम्म,
सर तो इसमें इसमें सी वाला ग्राफ तो सबसे पहले पीक पे पहुंच रहा है ना अगर अगर टाइम इक्वल टू जीरो से देखें तो सबसे पहले सी वाला पहुंच जा रहा है फिर उसके बाद ए वाला अपने पीक पे पहुंच जा रहा है फिर उसके बाद से बी पहुंच रहा है लास्ट में
इसमें देखो, इसमें क्या है कि यहाँ पे तुम्हारा जैसे है कि एट t is equal to 0 plus when we are starting
यस
the
सर
rotation of the coils. So
यस
at that time क्या होता है, तुम्हारा C फेज में जो है वो डिक्रीज, इस फेज में अभी कौन सा A B C है मुझे नहीं पता है, ठीक है.
यस
ये जो
सर
है इट स्टार्टेड डिक्रीजिंग. तो फर्स्ट पीक आने में जिसका सीक्वेंस होगा दैट इज योर फेज सीक्वेंस,
ओके सर
राइट.
ठीक है सर ठीक है
ओके,
समझ
समझ में आया कि नहीं है?
सर मतलब वो टी इक्वल टू जीरो के बाद फर्स्ट पिक कौन सी आएगी इसका मतलब ये है
राइट. टी इज इक्वल टू जीरो पे तो तुम्हारा इसमें ए डैश में जो था वो जीरो था वोल्टेज. नाउ
यस
जस्ट वी हैव स्टार्टेड द रोटेशन. बिफोर रोटेशन जो है सो वो कुछ इंस्टेंटेनियस वैल्यू था उसका.
ओके सर
नाउ दिस इज अबाउट द फेज सीक्वेंस. तो now since the voltage since the voltage is generated in each coil, then it can be considered as a source of voltage. ठीक है, जैसे कि एक coil है मान लो कोई, this was a coil, your A dashed coil. Now some voltage has been generated VAA dashed across this coil, then this can be considered as a source, right? So let us now connect some load across the each phase coil. This is your load.
कॉलेज में थी इवेंट हो रहा था हर साल आविष्कार नाम से
Mute yourself.
पार्टिसिपेट करने टीम रहे कंप्लीट करो फर्स्ट
All of you, please mute yourself. Okay. So similarly, we have another coil BB dashed. Again, let us consider a load connected across this BB dashed coil. This is your VBB dashed, and similarly for the third coil, this is CC dashed, this is VCC dashed, and this is your load, right? So if we want to supply the load with the help of the three single coils or three individual coils, A dashed, BB dashed, and CC dashed, then this arrangement will be this arrangement should be there in order to fulfill the three load demands, right? So this configuration is basically your equivalent to three separate single phase system. So such system is known as single phase 6 wire, or if we combinedly take this, then this will be 3 phase 6 wire system. तो एक पॉइंट लास्ट क्लास में मैंने बोला था जिस पे वी हैव आल्सो डिस्कस्ड समथिंग that in case of means single phase system is less economical compared to a 3 phase system because more number of conductors are used, right? Then how using the 3 phase configuration we can reduce the number of or volume of the conductor material required, so that we can understand. क्या चक्कर है? Just a minute. Okay. So, the number of connecting wires can be reduced by the interconnection of these phases to form a single three-phase AC source, right? So, how it is possible? So, there are two methods. Uh, two methods. There are two methods for this of interconnecting the three-phase system, which are a star connection और Y connection is also इसको बोला जाता है, and another one is delta connection, right? So separately we will see for the each configuration, that is we will first of all talk about the star connection. So how a star connection is formed, then first of all you will have to consider three separate coils. Let us consider the same coil. किसी का माइक ऑन है, माइक बंद करो सब लोग अपना. Hello, Krishna. Krishna, am I audible to you?
सर आप म्यूट एवरीवन कर दीजिए सर, शायद उसका माइक में कुछ डिफेक्ट होगा, ऑन रहेगा।
Okay. So suppose we have three coils, A dashed, B dashed, and C dashed. So if we have to connect this three coil in a star connection, then the method is that you need to connect the same polarity points of each coil. So suppose this is positive, this is negative, this is positive, this is negative, this is positive, this is negative. For the three coils A dash, B dash, and C dash, then you need to connect the same polarity point. या तो negative polarity के points को connect कर दो, otherwise positive polarity के जो terminal हैं उनको short circuit कर दो. So this will give you the star connection, right? The other representation is in this form, right? So this is your three-phase star connected system. ठीक है? Means you need to connect the same polarity points or terminals. Now here there is a possibility of neutral also. Suppose this is the neutral point N. So the advantage of using a star connection is that you have the possibility of neutral point or neutral connection. So a fourth wire brought out from the neutral point is known as neutral wire, right? So you have the possibility of the fourth wire also. Now what is the benefit of this fourth wire? So one example you can consider कि जैसे हम लोग के घर में जो सप्लाई आता है that is basically a सिंगल फेज सप्लाई, राइट? सो एक फेज और एक न्यूट्रल के बीच जो कनेक्शन होता है दैट इज योर, और जो वोल्टेज होता है दिस इज योर फेज वोल्टेज, राइट? और ये होता है लाइन वोल्टेज. तो किसी किसी के घर में देखोगे दो फेज का भी सप्लाई लेके रखते हैं लोग फॉर द रिलायबिलिटी पर्पस. इफ supply is interrupted in any one phase, then using other phase and the neutral conductor you can avail the supply, electricity supply. तो जो ट्रांसफार्मर लगा होता है पोल पे, that transformer is basically your this type of configuration, delta star, right? मतलब प्राइमरी वाइंडिंग जो होता है उसका डेल्टा कनेक्टेड होता है ट्रांसफार्मर का, सेकेंडरी वाइंडिंग इज योर स्टार कनेक्टेड. व्हाई स्टार कनेक्टेड? बिकॉज देयर इज ए पॉसिबिलिटी ऑफ फोर्थ वायर इन केस ऑफ ए स्टार कनेक्टेड सिस्टम, राइट? तो यहाँ से हम लोग 230 वोल्ट इजिली वी कैन अवेल इन आवर हाउस होल्ड. अदरवाइज लाइन टू लाइन वोल्टेज इज 440 वोल्ट कहते हैं लोग या 400 वोल्ट कहते हैं इन दिस वे. So this is the advantage of using a star connection, right? So in all distribution system, three phase four wire system is used. This is your three phase four wire system, right? Now if suppose we have to do the configuration for a delta connection, so how it is done? So let us consider three coils again. same coil A dashed, B dashed, and C dashed. So for connecting the three coils in delta, you need to connect the terminals of coils having opposite polarity, right? So suppose this was positive negative positive negative positive negative, then this terminal should be connected here, this should be connected here, and this should be connected here. Other possibility is also there. You can connect this A dashed with this B, then B dashed with this C, and this C dashed with A. So this is the configuration of a delta connection of a three phase network, right? उसको इस फॉर्म में भी रिप्रेजेंट करते हैं for the three phase, right? So you can see that the neutral का कोई possibility यहाँ नहीं है. You don't have any neutral point or neutral connection in the delta connected system. तो इसमें you can achieve only the phase voltage or line voltage. Basically both are same in this condition. The phase and line voltage is both, but in case of a star connection both are different, right? Now how to establish the relationship between phase and line voltages in a star connection. Separately we will see for the star and delta, right? So first of
हेलो
all let
सर।
us consider yes.
सर हर कॉइल में सर तो वोल्टेज वेरी कर रहा होगा सर अकॉर्डिंग टू साइनसॉइडल ग्राफ।
हाँ, एक इंस्टेंट पे इंस्टेंटेनियस वैल्यू विल बी डिफरेंट,
अच्छा सर,
राइट?
मतलब एक एक इंस्टेंट पे अगर तीनों पॉजिटिव है तो तीनों को साथ में कनेक्ट कर देंगे, ऐसा कर रहे हैं हम लोग।
एक इंस्टेंट पे देखो ना, ग्राफ देखो, अभी जो ग्राफ हम लोगों ने बनाया था
यस
ये,
यस सर।
जैसे कि मान लो कि कोई एक पर्टिकुलर इंस्टेंट ले लो, यहाँ पे ये इंस्टेंट, ठीक है? You can see that for phase A it is maximum, the voltage generated is maximum, but for both B and C phase the generated voltage is negative.
यस सर।
मैक्सिमम नहीं है, कुछ उससे कम है,
यस
राइट? तो हाँ, आप बताओ क्या कहना चाह रहे हो?
सर। तो सर हम लोग को पता कैसे चलेगा कि दोनों तीनों पॉजिटिव जैसे इसमें कनेक्ट करना है स्टार कनेक्शन में, तो
हाँ,
वोल्टेज वोल्टेज सर वेरी कर रहा है, तो मतलब ऐसा तो होएगा ही नहीं कि हमेशा तीनों पॉजिटिव मिले हमारे को।
नहीं नहीं, जैसे कि मान लो कि तुम जो है सो इंस्टेंटेनियस, जो कि हम लोग बात कर रहे हैं, एनालिसिस कर रहे हैं मैथमेटिकली, दैट इज स्टेडी स्टेट एनालिसिस, ठीक है? तो वो किसी इंस्टेंटेनियस वैल्यू पे हम लोग बात कर रहे हैं। अब जैसे मान लो कि यहाँ पे देख लो, इस इंस्टेंट पे देख लो, इस इंस्टेंट पे देखोगे तो बी के लिए और ए के लिए इट इज नेगेटिव, तो हर एक इंस्टेंट पे अलग अलग है। सो यू विल हैव टू फर्स्ट ऑफ ऑल ये जो इंस्टेंटेनियसली इसको कनेक्ट करना पड़ेगा। Just a minute. क्या नहीं समझ में आ रहा है क्या?
सर मतलब एक इंस्टेंस पे देखेंगे वैल्यू पॉजिटिव या नेगेटिव और फिर मतलब उससे कनेक्शन कर देंगे, ऐसा ऐसा होगा।
देखो ऐसा है, वहां पे जो ईएमएफ जनरेटेड है वी ए डैश या वी बी बी डैश या वी सी सी डैश, वोल्टेज है किसी कॉइल के थ्रू। इस तरह से समझो, मान लो कि ये टू टर्मिनल है, ये एक कॉइल है ए ए डैश, सपोज दिस इज डॉट, दिस इज क्रॉस, राइट? फॉर एनी पर्टिकुलर इंस्टेंट पे ये, ठीक है? सिमिलरली उस पर्टिकुलर इंस्टेंट पे कॉइल बी के थ्रू है, मान लो ये बी बी डैश कॉइल है, इसमें भी डॉट है, इसमें भी क्रॉस है, and suppose this is the third coil C C dash, this is also dot, this is also cross. We have just considered one example. So at any particular instant you will be knowing about the direction of current through the coil. Means dot का मतलब क्या बताया था? Current is coming outside, cross का मतलब going outside. तो यहाँ पे पॉजिटिव निगेटिव का मतलब वही है, मान लो इसको मान लेते हो डॉट को कि पॉजिटिव है, देन अनदर विल बी नेगेटिव. So you will have to measure the current either with the help of oscilloscope or with the help of analog meters, right? Then you will be knowing that which terminal is positive, which terminal is negative. अब जैसे मान लो कि प्रैक्टिकली इसको अगर ऐसे सोचें कि जैसे अभी मशीन लैब में तुम लोगों ने कुछ एक्सपेरिमेंट किया, ठीक है? सो एवरी मशीन मीन्स रोटेटिंग मशीन की अगर बात करें हम, या इवन ट्रांसफार्मर की बात करें, सो व्हाट हैपेंस इन केस ऑफ एसी सिस्टम? पहले पॉजिटिव निगेटिव का मतलब क्या होता है? If for the first half cycle the polarity will be positive, for the another half cycle it will be negative, so it will be changing with respect to the time. So whatever analysis you are doing instantaneous analysis, right, at a particular instant of time. तो कहीं भी एसी सिस्टम में हम अगर पॉजिटिव और नेगेटिव दिखाते हैं किसी सर्किट में भी, मान लो कि इस तरह से है, ये कोई एसी सोर्स है, यहाँ पॉजिटिव दिखाते हैं, नेगेटिव दिखाते हैं, इट मींस दिस इज इंस्टेंटेनियस पोलैरिटी, राइट, at any particular instant of time. तो इस तरह से आइडेंटिफाई करके यू विल हैव टू शॉर्ट सर्किट द टर्मिनल्स इन केस ऑफ स्टार कनेक्शन.
ओके सर.
ठीक है, ओके. तो इसमें जो है, सो नाउ द नेक्स्ट पार्ट इज वी नीड टू establish the relationship between the phase voltage and line voltage in both star and delta connection system. तो आज तो टाइम हो गया है, तो इसमें तुम लोग खुद से ट्राई करना. मैं एक कॉन्फ़िगरेशन बना रहा हूँ स्टार का. मान लो कि ये कोई एक स्टार कनेक्शन है, एंड दिस इज फॉर द थर्ड फेज, थर्ड कॉइल है ये. दिस इज सपोज ए, दिस इज बी, दिस इज सी. ये न्यूट्रल पॉइंट है, राइट. तो इसमें मान लो कि वोल्टेज कुछ जनरेट होगा ए और एन के बीच में, मान लो कि वी ए एन है. सिमिलरली हेयर ए और सी के बीच में वी ए सी है. दिस इज योर सॉरी, दिस इज सी एन. फेज और न्यूट्रल के बीच का वोल्टेज फेज वोल्टेज है. दिस इज वी बी एन है, राइट. एंड सिमिलरली बोलते हैं वोल्टेज बिटवीन एनी टू एडजेसेंट फेजेस आर सपोज वी सी ए, then this is your VAB, then this is your VBC or CB, right. So इसमें you have to just find the relationship between, the phase voltage VP and line voltage. So this VCA is your line voltage, VAB is your line voltage if we consider the identical system. VBC is also line voltage, and this VAN is equal to VBN is equal to VCN. I'm talking about magnitude, not the this phasor value. Magnitude, there will be some phase delay, you know that. This is your V phase voltage, right. ये होगा. Similarly, mod VCA is equal to mod VAB is equal to mod VBC is equal to V line voltage. तो VP और VL में क्या relationship है? Both in terms of magnitude as well as the phase. You have to establish the relation with the help of phasor diagram. तो ये स्टार और डेल्टा दोनों में ट्राई करना, सेम थिंग. ठीक, बाकी हम लोग नेक्स्ट क्लास में देखेंगे, राइट. एनी क्वेश्चन?
नो सर.
So I will end this meeting now. Thank you, everyone.
Thank you, sir.